Today I'm going to do some questions on paper, Edexcel paper, chemistry paper 1, advanced in organic and physical chemistry. That's 2023 paper. Okay, I'm going to attempt to answer some of these questions, or all the questions for you. One of the students requested me to have a go, so I'm having a go. So these questions about D block elements. Which of the labels 1 to 4 identifies D block elements in period 4? So it's going to be B, which is 2. Okay? So that's period 4 and it's a D block element. Question B. State what's meant to term D block element, an element which has its last electron added to a D subshell. Question 2. Chemists often use the term orbital when considering atomic structure. State what's meant by the term orbital. So this is a definition that you have to know, which is a region in an atom in which there is a high probability of finding an electron containing a pair of electrons with opposite spins. B. Draw diagrams to show the shape of an S and a P orbital. So the S orbital is a sphere and the P orbital looks like a shape of a dumbbell. C. What's the electronic configuration of copper atom? So copper atom has to be this A because it's 1s2, 2s2, 2p6, 3s2, 3p6, 4s1 and 3d10. It's got a full D shell in here. Therefore it's only got 1 in its S shell. Question 3. Which change, so this is about compounds containing elements in group 7. Which change occurs when concentrated sulfuric acid is added to potassium bromide? So the change is potassium bromide ions reduce sulfuric acid, forming sulfur dioxide. So you need to really understand this reaction, or know this reaction actually that happens. So sulfur dioxide is formed in here. Okay, B. Chemists can test the presence of bromide ions in solution by adding a small amount of acidified silver nitrate solution. The solubility of the precipitate in aqueous ammonia is then tested. Which statement is correct for bromide ions? Has to be a cream precipitate which forms that dissolves in concentrated ammonia only. It can't be a cream precipitate which dissolves in both dilute and concentrated ammonia because it doesn't dissolve in dilute ammonia. Give a reason why the silver nitrate must be acidified to remove any impurities such as CO2, carbonates, hydroxides, ions, which could lead to a false positive because they can react with silver to form silver carbonate, which will be a white precipitate anyway, or silver oxide. Explain which acid needs to be used to acidify the silver nitrate solution and why other acids are unsuitable. So you got a nitric acid so that an ion from the acid does not form a precipitate with silver ions because it's a nitrate. Okay, so you won't see any precipitate there. Question 4. The graph shows the melting temperature of some elements. You can see sodium here, which is lower, then it goes higher to magnesium. Stays sort of the same for aluminium for different reasons. And then increases all the way up to silicon and goes right down to phosphorus. So explain the variations in melting temperature across the period in terms of structure, bonding of these elements. Okay, so there are 6 marks. So you got sodium, magnesium, and aluminium are all metallic bonding in a giant lattice. So they're all giant metallic lattice, and they all got metallic bonding. There's an increase of charge of the ion from Na to Al. So strength of the metallic bonding increases due to the strong attraction between the localized electrons and positive ions, so melting temperature increases. What happens here, there's Na plus, magnesium 2 plus, aluminium 3 plus, so there's charge increases there. Silicon is a giant covalent lattice, so a lot of energy is required to break many strong covalent bonds, and it has the highest melting temperature. Okay? So phosphorus is a simple molecular structure, so only weak London forces between molecules exist, so are broken on melting, so very low temperatures, melting temperature is needed because very less energy is needed to break those bonds. Okay? This question 3C, iodine trichloride forms a dimer. in the solid state. When molten is suggested that it breaks down as shown below. So draw a diagram, the label diagram in a simple experiment confirm this dissociation has occurred, stating positive result. So this is your diagram, there's a heat here, there's a molten compound in there, and then you show the negative and positive electrodes there. That's all basically what you have to show. And then you got the positive results is in the bubble lights. What's the shape of ICl minus, ACl4 minus ion? So the shape is square planar, so because it looks like that. It's got 2 lone pairs, 4 bonding pairs. The equilibrium position for dissociation molten of I2Cl6 lies to the left. So which is the most likely numerical value Kc for this equilibrium? If it lies to the left, so it becomes towards the reactant, so it has to be less than 1. So therefore it has to be this one here. 5 times 10 minus 3. Okay? Question 5. This question is about the composition of nitrogen tetroxide. The research reaction eventually reached equilibrium, so you got all these values here, temperature in Kelvin and delta G. You plot them, so plot the graph delta G against temperature, so that's what I've done here. Then the next question is shown below. So it gives you a straight line, and then you're taking a gradient for the next question. So the next question says calculate the entropy change of system. So delta S system in joules, Kelvin minus 1, mole minus 1, using your straight line from the graph in A1 and the equation below. So you got the equation below. So if you got this equation is similar to this, therefore delta H equals to Y minus intercept. So the minus delta S is gradient. So the gradient M is minus delta S. So taking the gradient from the graph, okay, so it gives you the value of 0.18. So it will be 13 minus 30 divided by 495 minus 45. As far as I can see that, yeah. So the value gives you minus, gradient is minus delta S, which is minus 0.18, okay? Speed here, so once you have the delta S system, so gradient is this one here, so gradient is minus 100 joules per Kelvin minus 1 mole minus 1, so delta S is the value of that positive, okay, because that one is a minus delta S, isn't it? So it becomes positive value because it's minus delta S the system, okay, so it becomes positive value there. Maybe I should put here minus gives you positive. And what feature of the graph gives entropy change of this reaction has to be C-intercept of y-axis. B. What happens to the position of equilibrium and the color of the mixture when the pressure is increased? So the answer is C, moves to the left, mixture gets lighter. The reason for that, because if you increase pressure, it goes to the side with a smaller number of moles, because there's 2 moles in here and there's 1 mole in here. So you'll move towards the left-hand side, therefore it becomes colorless. So mixture gets lighter.